Добрый день, добро пожаловать на второй вебинар Института «Энергетическая дельта» совместно с Санкт-Петербургским газовым форумом. Good afternoon and welcome to the second webinar in the series of webinars of Energy Delta Institute that we organize jointly with St. Petersburg International Gas Forum. My name is Ekaterina Kravetsskaya. I'm the Marketing Director for Energy Delta Institute in Russia and Senior Business Development Advisor for a Dutch infrastructure company in the Netherlands, GasUnie. And we have a dedicated webinar today on the topic of well-developed and well-known technology of carbon capture, utilization, and storage that is employed now in the pathways to reach Paris Climate Agreement goals and will definitely play a significant role in decarbonization of the energy system in the future. Let me introduce now our expert of today, Leon Steele, in our studio in Groningen. Leon is the General Manager of Energy Delta Institute. Hello, Leon. He has a vast experience on this subject in research and consultancy from his experience in TNO, the Netherlands Organization for Applied Science Research. So, Leon, I hope you can shed the light for us today. What's happening in the industry, why we're seeing a revival of CCUS, what has happened before, and so we actually see some prospects in the future for huge scale-up of.
Yeah, I will do my best, Katja. Thank you very much. It's nice to be on the other side of the table for once.
Yes, sorry. Before I give the floor, I would like to say a few organizational points to the audience. This broadcast is being shown both on YouTube and on the event page. You can choose your language of the broadcast. It's been interpreted into Russian. You have received the presentation. You can download it also from the event page for your convenience. And we will also take your questions in the chat box of both platforms as we speak. And there will be also time at the end of the presentation for questions. So please be welcome with questions. And on that, I'm giving now the floor to Leon. Please.
Okay, thank you very much. Yeah, maybe we had one slide left on the Energy Delta Institute itself, but I think it's clear that we are a nice business school and do a lot of things for our audience. So let me just start with the topic of today. So CCUS, basically what is it for most people who don't know it yet? It's carbon capture, utilization and storage. If I look up the exact definition from the IPCC, it's a process consisting of the separation of CO2 from industrial and energy related sources, transported to a storage location and long-term isolation from the atmosphere. So it's capturing CO2, it's transporting it somewhere and then doing something with the CO2 to make sure that it will not enter the atmosphere for ever or for a very long time. You basically have four types of carbon capture that you can identify that is being used most often. So you have post-combustion capture. That basically means that before you actually do something with the fuel, for example, make electricity, you already capture the CO2. So before burning it, after burning it, it is exactly the opposite that you just said. Post-combustion is indeed after you combust something like in a coal-fired power plant, for example, you capture the CO2 from the flue gas and then isolate the CO2 and bring it somewhere. Pre-combustion is what I just said, is before you actually start combustion. So you have some kind of gasification or reform and capture system in between. It's often used in gas cycle power plants, for example, where they capture the CO2 before and isolate it. And then the hydrogen in this case goes to the combustion chamber to generate the power and heat that you require. So depending on what kind of process you're working with, you can either use those two. There you have a special one which is called oxy-fuel. And oxy-fuel is again it's a combination between a pre-combustion and a post-combustion. We can almost say you do something with the incoming air before, so you have fuel and pure oxygen that you combine together for power and heat. And that basically creates a very pure stream of CO2 afterwards, which is easy to dispose of. And then there's the industrial version. So the first three are usually only found in the power and heat sector. So using if you want to make electricity or heat. The industrial version is for industrial processes. So there's a process that is emitting CO2, can be steel, cement, all that kind of processes. Where you can actually capture the CO2 from a different part of the process. And there are different types of capturing. It can be also post-combustion, pre-combustion types that you can use. If you look at the right, there's a line, CCUS. It's a large project in the European Union. It gives a nice overview of how this works. where you have this this chain of events that in the end leads to the CO2 being stored, in this case underground in aquifers or old oil and gas reservoirs. So why carbon capture? Why did we even start with it in the beginning? Because it has been around for a while. The first experiments with it were already in the 70s, and in the 80s and 90s people started really looking at it as a way of a mechanism to quickly decarbonize. So in the beginning, I will show that a little bit later in the slide, that in the beginning the carbon capture and storage, or at least carbon capture, was used mostly in the gas industry. Because if you have a reservoir, a gas reservoir, usually depending on where you are in the world, some CO2 comes with the gas, which is called sour gas. So you have to remove the CO2. So there it was used in that way, and also it was used in chemistry to get CO2 and to make CO2 from to put it in as for a feedstock for chemistry, for example in fertilizer industry. But when the climate debate started and people were thinking, okay, how can we decarbonize our energy system quickly? Then carbon and capture came to the fore. So it basically enables cost-effective decarbonization of heavy industry and power. And it also, a very important aspect of that is it is a technology that is available, it was available, is still available, can be quickly applied, and you don't have to change your entire industry right away. So you can, it's an add-on to an existing industrial base. So you can make new, for example, coal-fired power plants, you can make them capture ready. That basically means you can put the carbon capture system right next to it when you want it. So it lengthens the lifetime of existing investments and also of new investments, which are cheaper compared to completely changing your industrial base. Another thing which is also interesting, because some CO2 is also a valuable commodity and can be reused, for example, in the chemical industry. So there are reuse options available for the CO2. So in theory, at least, CO2 is a valuable commodity. It is traded also around the world. It can have a very high price depending on where you are. If you use very pure CO2 for beverages, for example, it can go as high as 1,000 euros per ton. That is not uncommon, but the only problem with that is it does not require a lot of CO2. But still, it is a commodity. So it enables different processes, such as enhanced oil recovery, enhanced gas recovery, chemicals production, fuels, algae, things like that. So in that sense, you're not only decarbonizing, but you're also making a very pure stream of CO2, which is a valuable commodity if you want to reuse it at some point. So the current status of the CCUS system is very nicely summarized here by the Global CCS Institute. There you see that most of these systems that are used for carbon capture, like I said, came from gas processing and hydrogen production plants, and then hydrogen production more in the sense of for refineries, for oil and gas systems. So there were some pretty big systems already used, mostly in the States. The other one is more on chemistry. You also see a couple of these red bulbs that are chemistry related. They're also already for a while in the 90s and the 80s. From the beginning of 2000, the focus was shifted to the power industry, like I said, as a way of decarbonizing the power industry, mainly using coal-fired generation for that. But that actually never took off. So you only see a few examples of these systems being built, which is the Boundary Dam project in Canada, which I was personally involved in, and the Petronova project as well. But those projects were never, those are the only ones. So we will talk about Boundary Dam in a minute, but the ambition of Boundary Dam was to really scale up, to have the first industrial system that would have been a beginning of scale up of this technology, and also of a cost reduction, as you always see also with renewables like solar power or wind power. But it never really happened. But the interesting thing is that in about 2008, 9, 10, 12, that kind of years, it started to decrease if you look at the power industry, because these renewables became more cheaper. But then you see that now there's still a significant amount of project planned in the power industry, but only in the US. And they're also only for, how do you say that nicely, for sort of enabling the coal-fired coal industry to survive. So they're not, to be honest, that serious in that sense. But you do see a shift now, if you look at the upper right side, to other industries that are hard to decarbonize. So these are steel, cement, and chemicals. So only power in the US is still there because of coal stimulus, but I don't think that will take off very well, to be honest, because the same system still applies that also led to the failure of the other projects that were planned for the coal industry. But for cement, steel, and other industries, it is very interesting. And there you see this renaissance coming up. You see that people are looking at it again, also in relationship to blue hydrogen, for example. So that's interesting to see. So that's why I'm calling this presentation a renaissance, because you see that it's coming back up. A little bit about the actual project. So Boundary Dam 3 project I just mentioned, that's in the middle of Canada, and it's by Sask Power, which is a utility company over there. They had faced the problem that at some point the national government would set a CO2 limit, a CO2 emission limit on power, and that limit was half of what they were emitting at that time. So they had a choice. They either had to close a lot of their coal-fired generation, because most of their province was based on coal-fired generation, because they have a lot of coal mines nearby. Also, Boundary Dam is in the south of Saskatchewan, of this province, and there the coal mine, an open pit coal mine, it's only 20 kilometers away, and it actually started right next to the power plant, and then they started mining it. So now it's 20 kilometers away, but they have lots of coal left, so they didn't want to say goodbye to that. So they decided to go towards the route of the CO2 capturing and storage. You see there on the left side with the four, in the picture, you see the left side with the four stacks. That is the coal-fired power plant. And on the right side, that building with the two vessels that are sticking out of it, that is the CO2 capture plant. And that's one of the biggest in the world, if not the biggest. So this one captures 1.2 to 1.4 megatons of CO2 every year. But there now you also see a bit of the problem with this technology, is that it has a very large footprint, because this single system only captures the CO2 from one stack. So they still have 3 stacks to go that are just emitting the way they used to emit, and only the first stack they are capturing the CO2 from. And this project already cost around $1 billion Canadian dollars. So I think that is about 600-700 million euros. But that's only for one system. The interesting fact here also is that they do use the CO2 very useful. So there's also an oil field next to it, or not next to it, maybe 30, 40, 50 kilometers away. So they sell the CO2 to the oil company, Cenovus, and uses it for enhanced oil recovery. So that is a system where you use the CO2 to push out the remaining oil, and you get part of the CO2 back with the oil, which you re-inject in the reservoir. So in the end, it will remain there. And they also have a small chemical plant where they make some acids from the sulfur, I think, sulfur-based acids, and those they sell as well. So they have 2 streams where they are selling the CO2 to. That's quite unique. So in that sense, this technology or this project is still running today. But like I said, the ambition was to also scale it up to the other stacks, and that still did not happen, and I don't think they will ever do that. Another project that is almost coming online, and I think the investment decision is actually this month, the final investment decision, is in Norway. If you look at around the world where CCS was perceived and used most often, it was on countries that were reliant on coal, or had a problem with trying to divest of coal, but also on projects that were more on countries that had the ability to store the CO2. So in Canada, like I mentioned, some provinces were much on coal. North America was very big on CCS. Japan, Australia, the Netherlands, and Norway. And Norway is still one of the most the biggest advocates of CCS. So they figured out this Northern Lights project here, and then they shifted their focus from like I said, from the power industry towards their other industrial sectors. So here they're trying to capture. They will capture CO2 from an energy plant, which is a waste-to-energy plant in Oslo, and a cement plant, which is near Oslo. So combined is about 800 kilotons per year that they will do in phase one. I'm not sure why they say 1.5 million megatons per year. So probably get it somewhere else as well. But they will slowly scale that up over time. They'll start with 800 kilotons and then they end up with 1.5, and then in phase two they go to 3.5. They transport it by ship, which is kind of interesting. Most people always thought of the only way of transporting CO2 cheaply is by pipeline, but okay. They feel that the transport by ship is possible, and they go to an island with a natural gas park on it. So there's a small island that already has natural gas infrastructure, and from the island it goes to a geological storage, deep storage. This costs about 100 euros per ton of CO2. The other project I mentioned was similar, so it was also somewhere around that mark, maybe a little bit cheaper because they had an easier time of capturing the CO2. This is actually harder to do from cement and from a waste-to-energy plant because it's cleaner, not cement, but the waste-to-energy plant is actually cleaner than coal. So you have less CO2 in your flue gases, which makes it harder to capture. But okay, this is a very interesting one. This is actually the one that is the furthest away from actually being deployed. If that will happen, they expect that also other projects around the world and in Europe will start working again. Also because the European Union has looked at CCS again and put it in there. I think it's in the Green Deal, to be honest, at least parts of it. So it's pretty interesting to see that these things are starting again, but then for other industries. So why did it not take off in the first place? Because those things are still not entirely solved. The costs are the major factor in that. So the costs have always been too high. So you can see here that the cost so it's US dollars per ton of CO2. It's basically what the cost is at the moment and what they expect the cost to be. And also what it is in relationship to the carbon taxes that are being proposed or carbon prices that are being set. So the left side is how it is now. So the first of a kind technology cost. So you see that for gas processings and for bioethanol plants and fertilizers, the costs are relatively okay. It's 20, 30 dollars per ton of CO2. This is doable. Also, if you compare it with the what they expect for the carbon price, for example, the IEA. But then for coal, it's much higher. It's already 80. For iron and steel, it goes towards 90. Natural gas combined cycle, it's over 100. And for cement, it's somewhere around 130 euros. So this is just very, very expensive because there's no real business case for the CO2 yet. Most of the problems is how to get rid of that CO2, how to make it sustainable or financially sustainable. There's no real business case for the CO2 at the moment. So that's why you only do this if there is a financial incentive some other way. So you're forced because you have to decarbonize, or there's some tax somewhere that you have to pay, or there's a carbon price that is also slowly going up. Now they also expect that if you continue with this technology cycle, so if you start applying these technologies more often and at scale, then the price will go down. So then they expect that even iron and steel and also cement will be below the carbon price, below whatever kind of carbon tax they will introduce in the UK and in France. So in that sense, then you're good. But the gap between before you are at the price that you want to be is still a very long way away. And some other things that are interesting also, that also is a bit of a problem, is the public is quite opposed. We saw that there was a lot of public opposition to CCS. And then mainly on the storage part. So the storage part on land. In the case of Boundary Dam, for example, even there, this very low populated area with everybody basically working in that same coal-fired power plant, but there were still people protesting that you would inject CO2 in the ground and that you would leave it there. So even there they had problems. But I mentioned here the Barendrecht project, which was in the Netherlands, which the idea was that from the Rotterdam capture project, they would get CO2 from a coal-fired power plant. They would inject it in a reservoir, in an old gas well, actually, an old gas reservoir, natural gas reservoir, and people were protesting that massively because they did not really understand what the risks were. It was not explained very well. The people were not taken into this way of doing this, and they were opposed to it. So they were afraid that they were risk to the health, but also that, for example, the housing prices would go down because you're suddenly on top of a bulb of CO2. So in that sense, it was completely stopped. So up till this day, it is not even discussable or negotiable that we would have CO2 storage on land. So that's why we're looking, at least in the Netherlands, we're looking at sea, the same as the Norwegians. There's also a lot of NGO opposition. So CCUS, they say that CCUS will only divert from the implementation of the real renewables. And in a sense, they were right in that. It was always perceived for the electricity industry to be a step in between. And so you would have this CCUS on coal-fired power plants for 25 years, 30 years, until there's something better. But then you see actually that the something better in terms of price is already there. Coal is now most often even more expensive than solar or wind energy. So the NGOs opposed it massively. I'm not sure actually how they oppose it now for industry, because then it can still be a good idea. But they imposed it a lot that hampered the implementation of CCS in the power industry. In that sense, there was also a lot of unable and unwilling to formulate a steady regime for CCUS. That was also a problem, I think also because of the NGO and the public opposition. Safety. People perceived safety as a big problem. So there was the Lake Kivu incident, which is in Rwanda. There's a lake that has that is a bit of a special makeup. So CO2 is actually dissolved in the water, and it's a very deep layer. The lake is stagnant. But if there's some kind of disruption in the lake, for example, with an earthquake, then the CO2-bearing layer of water comes up, and it starts to come out of the water the same way as you have your spa bottle. But CO2 is heavier than air, so it stays on a layer on top of the lake, and if then the wind blows a certain direction, it can come on land, and it can suffocate people or animals. And that happened, I think, a couple of times, where some people were caught up in this cloud of CO2. But it's not something that you would normally expect if you do this kind of CCUS, because then it is 3.2 or 3 kilometers down in some kind of aquifer or water layer. If you manage that well, if you monitor that well, it's almost impossible for the CO2 to come up. But those things are hard to explain. And of course, NIMBY, not in my backyard. I think that goes for a lot of technologies at the moment. CCUS plants have a large footprint. You don't want to have them directly near your home. So that's just one of these things you have to take into account.
Leon, if I may interrupt you on this slide for a quick question, if I may. You mentioned on the downsides a few points here on this slide, including the safety issues and the political and the opposition of NGOs, etc. Do you see any, what is the major technological challenge you see for CCUS, for the supply chain of the CCUS, if any?
For the supply chain only, or for the capture?
For the capture.
The capture, well, that's it is a bit hard to explain, because most of these technologies are just there already. So from the technology perspective, we're actually fine. We already know how to do it. The only thing is you need to have this scale up. So you have economies of scale where you can lower the cost. So the main problem is still the cost. There is public opposition, but you can tackle that. But the main thing is still the cost. People are not really willing to do it at the moment, because there's still a lot of subsidies required to do it. And usually that's why this kind of project fails. So from a technology perspective, it's pretty good.
Yeah, so you need to scale up to get better economics, but you don't scale up because the economics doesn't look so good yet.
Exactly, yeah. So if there's no regime to support it, then people are not going to do it. That's the main problem.
Yeah, okay.
But maybe the other, there is one other thing that is interesting, that is important. If you want to have, you have to have a business case for the CO2. So on the other hand, you can either lower the cost of the capture, or you can make sure that the CO2 that you are producing has a value. So there are also technologies that are being investigated already for a long time, where you convert the CO2 directly into chemicals, for example, or fuels, or algae, or things like that. So you can directly sell them. But usually they are also still at a very low level on testing that out. So yeah, that's also things you have to take into account. Then
what about from the point of view of comparing with other CO2 mitigation measures? How is CCUS efficient from the capture of CO2 point of view? And how do they compete with other
Yeah, I know what you mean. It's a very interesting question. There are, if you look at it just by cost, and if you then only take the cost of mitigating CO2 into account, then coal-fired generation plus CCS is actually one of the cheapest. So the actual, it's still high, 100 euro per ton. But if you compare it, for example, that's also what they did in Norway. There's a discussion at the moment in Norway with this Northern Light project, is that 100 euros per ton sounds like a lot, but if you then compare it to decarbonizing by using, for example, electric vehicles, it's over 1,100 euros per ton to actually decarbonize in that direction. So that's 10 times more expensive. So CCS is actually quite expensive, or quite cheap compared to other options you have on decarbonizing. So it's a bit strange that we don't use it that much more. I think
and in lowering CO2 emissions, does it seem to be quite efficient compared to other technologies?
No, I don't think it's that. It's also it is efficient actually. It is more efficient, but I think it's maybe not as we call it in Dutch, we call it aaibaar. It is not so a technology that speaks to the hearts and minds of people. You know, it's a very large industrial thing that you're putting in there. It is very abstract. And for example, solar panels on your roof or using electric cars that consumers can use directly just speaks better to how people perceive the energy transition to go. But of course, if you look at it from the whole big perspective, we still need to do all these other things as well. So I think that's the main reason why this is not being, it is just hard to sell to do this. That's the main problem.
Hopefully it is hard to sell yet.
Yet, yes. I think we were looking at it. You were saying about the price and about the capacity to do this. There are a lot of technology. There are a lot of people that say, okay, without CCS we're not going to make it. So if we indeed look at decarbonization potential, then we have to take CCS seriously. So McKinsey also in 2019 on the left side in industry, they checked different ways of decarbonizing with CCS, and depending on the reference case. So in this case, the reference case would be the current electricity price in between and the low electricity price. And there you can see that if you use CCS in the current electricity price, you have the highest potential of actually decarbonization. So you have 5 million tons or gigatons, I think this is even gigatons. Yeah, gigatons CO2 that you can reduce. And even on low electricity price, it's still higher than using than efficiency gains, than electrification of heat, than using hydrogen as a feedstock is almost the same. So it makes sense in a lot of different directions, cost-wise at least, and also with the potential-wise to do CCS. And another thing that is interesting is also the hydrogen discussion. So hydrogen is being perceived, at least in Europe, but also I think around the world, as a very good way of decarbonizing your energy mix for transport, for industry, that kind of things. But also there's the question, okay, in the end people want to go to green hydrogen, so 100% decarbonized renewable, or not decarbonized, 100% renewable hydrogen from renewable energy. But if you look at the price of that, at the moment it's nearly 700 euros per ton. If you use blue hydrogen, which is the variant where you take the CO2 out of the natural gas and you produce hydrogen directly, and then you store and reuse the CO2. There you see that the cost price is much lower. So it's between 110 and 150 euros per ton, depending on who you believe. So also if you want to really start with a hydrogen economy or with a hydrogen industrial system, because now there's nothing in that sense for hydrogen. There's only a lot of potential. There's a lot of promises to do, and there's also a lot of money at the moment to do it, but there's no real system yet. So if you then want to make sure that you have a hydrogen system ready and available quickly, why not use this blue hydrogen first? Because it's much more cheap, it's 7 times or 6 times cheaper than the green hydrogen at the moment. So then you can kickstart that technology chain as well, while at the same time also reducing the cost of CCS. So in that sense, I think it makes very much sense that you see a revival of CCS technologies for both industry and for hydrogen, because they can have a significant effect on how, on our decarbonization agenda.
Leon, we have a question from the audience, if I may interrupt at this point. The question is, are there any projects where CO2 capture is organized by airless combustion using oxygen? What do they think to do in nitrogen oxide cement projects?
That I don't know from the top of my head. So I have to look it up. So I'll look it up later. But there are some projects where they, for the cement plants, they are looking at it, like I mentioned, so Northern Lights at least. But there are more that are ready to do that. But I'm not entirely sure about that, those kind of projects. So I have to get back to you on that.
There is one additional to this. Is converting CO2 into chemicals more efficient than creating chemicals from fossil fuels?
No, it's not more efficient. It is, if you capture CO2 and then you have a pure stream of CO2, the CO2 is a very unreactive molecule. So yes, you can use it and you can make things out of it, but you still have to add heat or energy to actually make it react into something else. So from our system that we use now from fossil fuels, is actually more efficient in that sense. Not maybe compared to climate emissions, but for the actual chemistry, it is more efficient at the moment. So it's a way of making CO2 useful, but it is not. If you just look at it from a chemistry standpoint, it is not the best way to do it because it's a very low reactive molecule.
Okay, thank you.
No problem. Like I said, so one other thing is that is also spurring this renaissance a little bit is that the ETS price, so the price of carbon is actually soaring. It's sort of roared back into life, according to Bloomberg. So you can see in the financial crisis in 2008 it was zero. And then it popped up again, I think, because they removed a lot of these rights. But now you see that it was so low that people basically ignored it. So if you wanted to have a lot of emissions, you could buy off your emissions with this system because they were quite cheap anyway. But now it starts to come up again. So I think they will take some steps as well within the new Green Deal, to actually make the price even higher. But once it becomes 30, 40, 50 euros per ton, then it becomes interesting. Because for 50 euros per ton, it's pretty doable to have a large-scale CO2 carbon capture system. So then it becomes cheaper to install something like that instead of buying these rights. And also maybe from the public perspective system, I think it's also good to do this. But so in that sense, we are helped now with these the ETS price, which is something that was always the idea of the EU, but never really took off because there were simply too many rights available. So the market was oversaturated with this. But now it's slowly going up as well. So this can be an interesting tool to watch and see if people are reacting on this and making these projects more possible. Another thing is carbon taxation. So these are all the countries that have some kind of carbon taxation or at least plans to put carbon taxation into place. It's actually a significant amount, even China. They are China is actually implementing the, I think it's, what is it? I think it's the trading scheme. So they are, but all these countries, even Europe in total, is doing something about that. Now China, Australia, so all the countries I mentioned before, also some states in the United States, not the whole United States, they're really looking into how to tax carbon to a certain extent. So, and if you then do that, if you create this price and you make sure that the price is higher than the technology cost or close to the technology cost, then we're getting into a business case. The only thing, of course, we have to be careful with this is that this is not you do not build a large-scale carbon capture and storage plant for 5 years. You build this for 20 years or 25 years or 30 years. So people should, or politicians should take care, also with these incentive schemes, that it is fixed for a significant amount of time. Because otherwise people are not going to make this kind of huge investment deals. They can maybe do it with solar panels because the investment in that sense is a little bit lower. But if you are looking at €1 billion to invest in a carbon capture and storage plant, then you want to make sure that your business case is still valid over 10 or 20 years. And that's something that up till now was not really guaranteed for most of these technologies. So the incentive schemes were very much varied over time or even changed depending on the political color of the country. or on NGO pressures or things like that. I mean, the project I mentioned with the Boundary Dam project, for example, they did not get any incentives based on the production of CO2, but they did get incentives based on an investment. So they got some additional, they got some money from the state, some money from the federal government, and then they could build at least this plant. But the rest, the operational expenses, they had to make back themselves.
Leon, there's a question about the infrastructure part of CO2. Mm-hmm. Could you say a few words about transportation of CO2 by pipelines and the economy of that?
The economy of that, or the technology?
Yes, the technology, but also the economic aspects.
Okay. Yeah, it depends a little bit on how far and how much, and if you are able to reuse some infrastructure. Because the idea in that sense was also that you are going to reuse gas infrastructure, for example, in the North Sea. So these pipelines you can basically reverse. The main cost in that is, if you already have the pipelines, then those are not a high cost, but the main costs are in the compression. So you have to have, you get the CO2 as a gas, then you have to compress it to make it supercritical mostly, or liquid form, and then you inject it in the reservoir, which is another compression step. So if you look at the price, we had in the Netherlands we had a road project, so the Rotterdam project for capturing CO2 coal-fired power plant, that never happened. But if you look at the price build-up in that sense, then the 65 euros per ton, I think they were estimating in total for capturing CO2 and then transporting it and injecting in the reservoir. I think 6 euros per ton was for the transport part. So about 10% of that was for the transport. But it really depends on where you are and how far away is it. In the Rotterdam case, they had these pipelines available. They had to, of course, invest in the compressors, but they also had the reservoir itself available to do it and the injection point. But usually you have to make it liquid or supercritical state, and that's the most cost.
Yes, thank you. There are more technical questions coming, honestly.
Okay.
A bit more specific, maybe. Which equipment is used in this technological process of capturing, transporting, storing, injecting? But I think that's a little bit like long chain that has been mentioned. In capturing and storing CO2, which equipment has been used in capturing and storing CO2?
Well, mostly of these capture technologies, well, at least what I've been involved in, but I think also the biggest projects are either in pre-combustion capture. So for natural gas plants, for example, getting the CO2 from out of the stream, and also post-combustion capture. And post-combustion capture is amine based. So post-combustion capture is based on a solvent, and the solvent is usually an amine, and the amine captures, binds the CO2 from the flue gas, from the stream, and the chemical goes to a regenerator, and there it is heated up to about 135 degrees Celsius, something like that, and then the CO2 comes out of it again in gaseous form, and there are different varieties on that. So you can tweak your solvent depending on what you have. If you have a lot of hydrogen sulfide or hydrogen compounds or sulfur compounds or anything like that, then you have to have a little bit of different mixture. But in essence, that's the same technology. So most of that Boundary Dam was based on that. I'm not sure about the Northern Lights project. I think for the waste to energy plant is definitely based on a solvent capture. But there are other, for the cement is probably something else. And so yeah, those are the most used technology at the moment.
And another question about the safety requirements for the equipment is what about environmental supervision for safety aspects of the equipment that's being used? Is this a big question? Is this an issue?
Yeah, that's also something that varies a little bit over the world. But there were indeed, one thing you have to look at is that for post-combustion capture from flue gases, these amine systems, they started to you have a degradation of the solvent at some point. So the solvent itself is not forever. You have to replace it over time, but you also get a degradation of that. So sometimes, depending on your conditions, you can have that a part of the solvent actually leaves the stack together with the flue gas where you capture the CO2 from. So these components called nitrose amines, and these are chemicals that can be bad for you. So they're also in beer and things. I'm pointing at my water. This is just water. It's no beer. But they're in beer as well. So they're naturally occurring chemicals, but on higher concentrations they can be dangerous. And a lot of effort went into figuring out what is happening in the solvent, how does it degrade, and also how much of these nitrosamines or other bad components come out of the stack. And that really depends on how you operate your system. So sometimes they had a lot. So sometimes it was basically raining nitrosamines, but sometimes it was almost nothing. And it really depends also where you are. If you have in a residential area, of course, you have to be more careful. And otherwise, but usually, in general, it's not a big problem.
Yeah. Thanks. I think it's time to move on.
Yeah.
Perhaps.
Okay, now just some new projects. Well, one of them already mentioned on, so that's the Northern Lights project. Some other interesting ones is in the Netherlands we have a waste incinerator plant that recently installed a capture unit, also chemical-based capturing, so 60 kilotons per year. Interesting here is in the Netherlands we have a large greenhouse area where they have this greenhouses made from glass, and there they also have a pipeline. So it's called OCAP pipeline. So they get it from the refinery in Rotterdam. They already get pure CO2. They put the CO2 into the greenhouse to make the plants grow better. So in that sense, it's actually quite nice. These AVR is also selling this CO2 to the greenhouses against a nice price. So I mentioned 50 euros per ton would be nice. I think that's also approximately what they ask for the greenhouse CO2. So there, the business case is already apparent. The only problem again is it's already full. So the OCAP pipeline can expand a little bit. So now I think it's 1.5 million tons per year or something like that. It can go to 2 or 2.5 maybe, but that's it. So then there's no more room to put additional CO2. So you cannot sell it anymore after that room is being made up. So one coal-fired power plant or one boiler in a coal-fired power plant is 1.5 million tons of CO2 per year. So what the hell are you going to do with the rest? But okay, for AVR it works. Porthos is something similar. It's a bit of a different taste compared to the road project. Here they look at industrial clusters more instead of power. So they want to make some kind of ring line pipeline in Rotterdam, where people can put their CO2 on that pipeline. So the Rotterdam harbor will be sort of responsible of managing and putting in that pipeline, and then the industrial clusters themselves have to go and capture it and then can put it on the pipeline. Here you also see that they are looking at greenhouses as one way of disposing of the CO2 with a value, but they also, of course, because they see that it is full, they will put it back into in these platforms, the P18 platform that's across the harbor mouth, I think 20 kilometers from the shore, where they can put it back into an old gas field as well. So that project is I think it's in the feasibility phase, or it's past the feasibility phase, and they're looking at how to implement it further. Another one that actually has been built, excuse me, is the Abu Dhabi Steel. There's an Abu Dhabi Steel 1 apparently, 0.8 megatons per year, and there they actually capture the CO2. I'm not sure what they do with it. I hope they inject it into a reservoir, but it's a project that is actually happening. So that's a good one, nice one at scale, where you can see that this industrial potential is higher than the power. A little bit on CO2 utilization options. Like I mentioned, you can either reduce the amount of cost in the CO2 part, in the capture part, or you can see that if your CO2 can actually be converted into something useful that has a value. So that last part is also interesting to see. Here there's a graph that details all these different ways of using CO2 for something and their value and potential. So the higher it is, the more. If it's zero, then it's actually a good idea. Then you can do it. Then it brings you money. If it's positive, then it costs you money, or a little bit at least. So here you see that on the low scenario where they see there's very little application of this technology, There are some ways like EOR, biochar, urea, things in forestry that can actually make you some money if you do it like that. If you're on the high side of it, so if you say, okay, these technologies are being applied worldwide, everywhere, and people are really cutting the cost and making the process of converting the CO2 into something useful or using CO2 in the process very seriously, then you see that for methanol plants, biochar again, forestry, biomass production, that kind of thing, it becomes also more attractive to do it. But now the demand for these chemicals, like urea, for example, or biochar, is not very high. Also for EOR, people are not really using that much of CO2 for EOR. You can also argue that once people start getting out of oil, then why would you then still be able to sell the CO2 for EOR? Because that also is additional cost for your reservoir and production of oil. But okay, these are possibilities to do. They're interesting possibilities as well, because that makes the business case.
There's some questions about the business case, in fact, here.
Okay.
From the audience, if we could take a few. About the costs, again, how much will it cost a ton of CO2 emissions in Europe for industrial companies? Could you give us an example?
How much it will cost for industrial companies?
How much, yes, will it cost for a ton of CO2 emissions in Europe for industrial companies?
There's a bit of you have to look at it at 2 points. So I think for cement, for example, and steel, it's about over 100 euros per ton to capture the CO2 if you use this kind of technologies. Now it's in that sense cheaper because this ETS price governs how much it costs. So now in theory it's possible, I think in practice to do it too, to just buy these rights from the ETS. So if you are emitting a lot of CO2, then you can buy it for 25 euros per ton. So in that sense it costs 25 euros a ton.
Mm-hmm. And there is a specific question also about the Northern Light project, about if you could divide the cost of 100 euro per ton of CO2, how does it distribute amongst the transportation, capture, and other processes?
That I'm not exactly sure, but usually, like I said, with the road project, these projects are similar, except that for the Northern Lights, they also use ship transport at some point. So probably the transport option is a little bit higher, but I think that about half of it is actual capture, and then maybe 10, 15, or 20% is transport, and then the rest is injection and monitoring. So usually it's about that. Definition, yeah. But like I mentioned before, so if these tax incentives come, or these incentives come, and the carbon taxes increase, or the ETS price increases, then these options become more profitable, and it becomes better to at some point use this. For example, with the urea production, it's very feasible that at some point it is better to use CO2 that you capture from another process, or you get somewhere else, instead of using fossil fuels directly, because then there's a penalty of using the fossil fuels. Good. A little bit my conclusion at the end of this presentation. So CCUS has always been an option to quickly decarbonize industry and power. I think it still is. It's still the technology-wise we are at. Like the question that Katja gave me, is that technology-wise we are there. We can do this. We can just start. But the question is, okay, at what scale and how quickly, and do we want to do it like this? Initial start for the gas and refinery sector, and then it was used for CO2 capturing of gas reservoirs, and also for refineries, production of hydrogen, for example, and things like that, and for chemistry. The power sector came later, but it failed to take off because of the high price of CO2 capture compared to all the alternatives. Basically, the alternatives became cheaper, quicker, and also public and policy opposition. So recently people thought, okay, this can still be a good idea to decarbonize the industry, because it's hard to decarbonize industry fast enough as well, but also somewhat economically feasible. So there you're talking about steel, cement, chemicals, heavy industry, and also for blue hydrogen. For hydrogen itself, it can be a way to pave the way for a hydrogen economy. So the current focus is on these large-scale industrial pilots, and some coal projects in the US are in planning. But like I said, I not really believe that, because the whole coal industry also in the US is going down rapidly, despite what Mr. Trump says it will do. And utilization is now mainly still, CO2 utilization is mainly still in EOR and EGR, so in enhanced oil recovery or enhanced gas recovery. And then some greenhouses are using CO2, at least in the Netherlands, but also in other places, and some chemicals. It can be used for fuels, building materials, and algae. They're coming up, but they are still very expensive compared to the normal way of doing it. But it is an interesting system to watch out. So that is my talk.
Thank you, Leon. Very interesting discussion. I think so far you gave a lot of insights into the industrial parts and what's happening. Talking about the market perspective a little bit and the future potential for, you mentioned a few drivers already for potential scale up, which is hydrogen can play a role to lift it up a little bit off the ground. Also, of course, the economics is important. Do you think CCS has finally gotten enough political support and political incentives for companies to really start looking seriously in FIDs and really progress a little bit fast with their decision making?
It depends on the country. So for example, Norway, like I said, they're very active in that. So Norway really, also Northern Lights is being invested massively if it goes through. It will be a massive investment from the Norwegian pension fund. So these things are really supported by a single government. I think EU-wide it is still not very well supported. They mentioned it in the Green Deal. They mentioned it as a way of decarbonizing industry and things like that. But because it is not considered as a real renewable, it's still a difficult discussion to put that in the political EU system. Maybe just to mention, there are, if you look at outside EU, there are actual already projects that are happening and starting that are feasible just by itself, so without any incentives. In India, there are several capture projects already, where there's a chemical plant, for example, that requires CO2, but cannot get it at a normal price. So they are capturing the CO2 from their own gas-fired engine, which is used for electricity production, and then they use the same CO2 in their own process. So that kind of thing, if you look at it from, in Europe and North America, and probably also in Russia, it's the infrastructure of chemistry production and chemistry transport is pretty good. But if you are at countries in Africa, for example, or maybe even in parts of Latin America or in India where there's not so good, then it can make sense to just capture it yourself directly from the source.
Yeah, and of course, you mentioned about the depleted gas fields, of course, availability, which is also another, which makes also another country, for example, like Russia, potentially interesting to at least build these projects here, and especially in the case of increased pressure from the Green Deal policy and for exporters and to try to more decarbonize their supplies of energy to Europe. That would need to, we would need to see this more and more, I guess, that Russia would have to invest in CCUS projects here. Do you see Russia becoming a player in this business?
It can be. Yeah. I mean, it can be. I mean, the things that you require for this kind of technology, of course, is indeed, like we said, so you have to have some kind of infrastructure available, gas infrastructure, for example. You have to have these reservoirs available, but you also have to have space. So it's easier to put this kind of industrial plants not into living areas, but put them somewhere where you can be far away and the risks are low and there's nobody complaining about the smoke. So it's better to do it in that sense. So Russia, in that sense, is actually pretty good. So you can use it from Russia is in a position, for example, with hydrogen, to provide Europe with blue hydrogen if they want to do that, and if we are able to pay or willing to pay for it. But on the other hand, the CO2 production can also be used in Russia for legacy fields of oil fields or gas fields or things like that, to re-stimulate these fields and produce more oil and gas from those fields as well. Because some of these oil fields are I think most oil fields actually in Russia are slowly, production is slowly going down. So that costs additional. So with a low oil price, you're probably not going to do this. But in the longer term thing, you can really, okay, what are you going to do? CO2 is better for reservoir stimulation than water, what they are usually using. So in that sense, Russia is in a pretty good position to do this if they want to do it.
Yeah. So do you see that it can also very well become an international business rather than a localized business for CO2 transport, I mean, across borders? Should we see that happening in some future? Or is it going to be still more localized industry that every country will, just have a few projects for its own industrial decarbonization?
I think it will probably be more localized. I think it's the technology sharing or the technology application that is probably going to be very international. It already is. Even the Boundary Dam project has technology from Japan, and also in Norway is the technology from Canada. So in that sense, they're already having this technology transfer. But I think for actual CO2 transport, that is going to be very local. That you would want to have that, because it's not that easy to transport CO2. And it's also something that is, like I said, at the moment has no value, but it can have value in a later stage. But I think people are more willing to get rid of it than actually transport it somewhere else to do something with it. So in that sense, I think it's more local system.
Yeah, talking about pipeline of CO2, there's a question from the audience. What is the standard length of the current used pipeline systems that are already perhaps in place or that are being built?
No, I can only mention the ones that I know of. But like, for example, there's this road project and also Porter's project. The pipeline would be 25, 30 kilometers, something like that. I think in Northern Lights it's a little longer from that island, the natural gas parking island. I think it's probably maybe 100 kilometers or 150, something like that. And in the case of Boundary Dam, there's actually a reservoir right next to the plant, so then it's very short. It's maybe less than a kilometer. But if they then produce it into the network for EOR, that they usually got the CO2 from the United States. So they got it from the Dakota gasification facility. That was already a pipeline, CO2 pipeline to Canada. And there they just put their pipeline next to it, or they had a connection with the pipeline. So I think then maybe a couple of 100 kilometers, something like that.
So would you say then that for longer distances, then CO2 would primarily be transported by ship? Like beyond around 5?
Actually, I don't think you should transport it by ship. I think you have to transport it by pipeline. I don't think ships is a good idea, to be honest. I'm not sure why they even did that. But if you look at the volume that you can get into a ship, how you do that, it takes a significant amount of effort to produce or to sort of transport only a very little amount of CO2. So for a pipeline, it's much better to do it like that. Well, volume-wise and cost-wise. So I think Northern Lights in that sense is an exception.
Yeah. Okay. There are a few more questions. Maybe we still have time for one or two about a bit technical about what about airless combustion and economy of capturing. Can you give examples of methods that are already in use?
That I don't know. There is our airless capture in use. That I know for sure, but it's probably more only in the testing and piloting phase. So small scale pilots, things like that in the kilogram sphere, maybe a little bit higher than that, but not in the tons per hour that we require for CCS to take off.
And what about German plans to close up coal power plants? There's a question, do you see that perhaps CCUS could also help to keep some of these plants working? And do you have an opinion about that? Is there a chance that...
No, I don't think there's a chance for the coal-fired power plants in Russia or in Germany to be opened like that, because it's at some point that you also saw that in CCS in general, it becomes more of an emotional discussion. So if you look at the actual cost, then you can say, okay, maybe it's better to do it like that. But once they decided to go and close all these coal-fired power plants together with closing all the nuclear power plants, now I don't think it's a way back. Interestingly, in Japan, they are opening coal-fired power plants. So in Japan, they are actually, they also want to reduce their nuclear generation, and they want to replace part of it by coal-fired power plant. So that's actually quite interesting. So maybe they can be made capture ready to do that. But for electricity in general, this is a lost cause. So CCS on electricity generation, that is not going to happen. There are just too many alternatives now that are more cheaper and more easily to implement. So no hope for the coal-fired power plant in Germany, sorry.
And we have the last question from my side about do you see that there are a lot of projects, of course, being under development? We see, some FIDs are still planned, too many in construction. Do you see that there will be some competition among the projects, or there'll be enough demand for all of the CO2 capture and storage from the industry? How big is the demand, and is there enough for all of these projects to come on ground?
Oh yeah. Now maybe you mean competition in the sense of money or of technology? Yeah, the market. Yeah, well, there's no real market yet at the moment, so that has to be created by implementing all these projects. So these projects are now being financially based on what kind of local reason there is to do it. So there's no real global market or global incentive to do it yet. That was also a problem before, but there are still companies out there that have been able to reduce the price of capture already significantly. So there's that used to be a startup, Carbon Clean Solutions. They're actually from India, but they're based now in the UK, and they claim that they can go as low as $30, maybe $40 per ton of CO2 capturing. So in that sense, they have a very good position to start getting this market share once we start again, because most of the big players have stepped out of this technology.
First come, first serve. Whoever starts really operating first gets the largest demand.
Exactly. Yeah.
Okay, I think it's time-wise. We are close to finalizing the webinar. I think I'd like to thank you for a very informative presentation and a very interesting discussion.
Yeah. Thank you very much. I enjoyed it.
For those of you from the audience who are interested to learn more about the value chain, Energy Delta Institute will organize a dedicated program in fall with an expedition to Norway with a site visit. So please let us know about your interest and we can send you more information. Also, next week, there's an upcoming webinar, a third one of this series coming up. It's on global gas markets in the times of instability. We are going to expect more interesting speakers, so please register and stay connected with us. And for the rest, I would like to thank you for your attention, and we would like to wish you a very nice day. Thank you, Leon.
Yeah, thank you very much, guys. Yeah.
Very nice day to all of you.
Yeah.
Goodbye.
Bye-bye.